describes the different equations with their weights. Okay, so we have solved the difference equation, and suppose one given system is there, then we are able to find out the output expression. Okay, output expression we are able to solve. So basically they are used both FIR and IIR system, and very much advantageous in solving the IIR system. Okay, because in IIR system the impulse response is infinite, so we cannot easily apply the convolution theorem, convolution property. Okay, here convolution property tells that if it is finite, then it is very easy to calculate. But since the number of samples in the impulse response is infinity in case of IIR, so differential equation is very much useful in solving those. Now we'll discuss on another PPT I am opening now, that is yeah, on Z transform. Okay. So is the PPT visible?
Yes, sir.
Okay, fine. So there you can see that it is Z transform, invert Z transform, and solution of difference equation. Okay, part 3. I hope mostly you have idea about Z transform. Okay. So what do you mean by Z transform? Okay, that you can see it plays the same role in the analysis of discrete time signals and LTI systems as the Laplace transform does in the continuous time signals and LTI systems. And it offers the techniques for digital filter design and frequency analysis of digital signals, okay, or discrete signals. So discrete signal is converted into digital signal. Analog discrete signal is analog signal, so it is converted into digital signal, and then it is processed. So it is called digital signal processing. Okay. Now, if you have the discrete time information xn and its z transform is xz, so it is defined as this expression: xz is equal to n is equal to minus infinity to infinity x of n z to the power minus n. Okay, x of n you see may range from n is equal to minus infinity to infinity, and for all the samples, okay, of the input xn signal, okay, it is multiplied with some complex variable z. Okay, z is equal to what? R into e to the power ej omega. Okay, so actually it represents cos omega, okay, plus r into j sine omega. Okay, so r is the radius. So omega is the digital frequency. Okay, omega is the digital frequency. So if you assume that phasor is there, so its phasor is r cos omega is the real part, and r sine omega is the imaginary part, okay, of the phasor rotating at frequency omega, digital frequency. So each sample is meaning each sample is actually having magnitude xn, and we assume that there are the signal is transformed into sine and cosine waves, okay, and their magnitudes is the magnitude equal to, yeah, this one, x of n, okay, Now you can see, you know that this is the basic formula. Okay, what is most important parameter for Z transform is the region of convergence. Okay. Region of convergence is what? Suppose if you get the expression in terms of Z, so xz is the Z transform having in the expression in terms of Z. Okay. So this whole expression should not be infinity. Okay. So so for the values of Z, the functions become finite or exist. The values for which the functions become finite or exist is called region of convergence. So it is very important factor. Now now you see that if it is a one-sided signal, it is a causal signal. Say xn is equal to u of n, the causal signal, right hand signal. Okay. So Z transform exists from n is equal to 0 to infinite. Okay. And where un is your xn, so it is multiplied with z to the power minus n. So in series, we get this one, 1 plus z inverse plus z inverse square. Now according to the Z transform formula, according to the formula of series, that xz is now can be written as 1 by 1 minus z inverse. Okay. Now this xz will be finite if for what value? If, can you tell for what value of z this will be finite, this xz? Can you tell?
Sir, if z is not equal to 1, then it will be finite.
Yes, but not is equal to 1. But if it is minus 1, then it is finite. So you see that z, so not a particular value, okay, not only not z is equal to 1, it is actually range of values. So we can see that if this magnitude of z inverse is less than 1, okay, magnitude of z inverse is less than 1, that means mod z greater than 1. So magnitude of z is greater than 1, then only it will be finite. So otherwise it will be infinite. Okay. So mod z means both positive and negative value. Okay. Now this is the region of convergence of z. Okay. Now another expression. Okay. So that means if you assume that here one important property that mod z greater than a 1. So what we assume that this one z is a complex variable. So r into e to the power j omega, it is equal to what? R into e to the power j omega. So both r is the magnitude, okay, of the expression e to the power j omega. R is magnitude and this part is complex variable. So this r actually should be greater than 1. So r is what? It is actually radius of the phasor, radius of the phasor. So that radius of the phasor, it tells that should be greater than 1. So the ROC exists outside the unit circle. You can see that it is a r greater than 1. That means it is, if you say some circle is there having radius 1. Okay. So the outside, the ROC exists outside that circle, okay, in Z domain. Okay. So that is mod Z greater than 1. So for causal sequence or unit step sequence, ROC should be greater than 1 or outside the unit cycle. Okay. This is very important property, and lots more property we will see. It will be very clear. Now, second example. Second example is that if you consider the unit one signal a to the power n un, okay, where it is a causal sequence but it is exponential sequence, where the value of a can be anything, okay, like greater than 1, less than 1, okay. So both in positive and negative side. So in that case, okay, so how it will converge? So we have used this causal sequence. So you see that again AZ inverse 1 by this series actually it can be written as 1 by 1 minus AZ inverse. So this AZ inverse, mod of AZ inverse should be less than 1. So mod of AZ inverse less than 1 means mod Z greater than A. Okay. Mod Z greater than A. Then only it will be finite. So in this case, ROC lies where? Can you tell? ROC lies where for this sequence? Can you tell?
Sir, outside the circle of radius A.
Outside the circle of radius A. Okay. So for this case, we have this. So it is a causal sequence. Okay. Now another. So other of people, what you are all doing, you are just should not be a mute participant. You should take in the part in the interactions. Okay. Otherwise, it will be not clear. Okay, and it will take much time if you don't ask anything. And it will be also easy for me to make you understand. So other person should not be a mute participant only. So here, uh, so here you see that right-handed signal. A very clear description of one expression is there. That is again that signal a to the power n un we have considered. Okay, so it is a radius a. Okay, radius a, and ROC exists outside the circle of radius a. Okay. Now question is, if the value of a is less than 1, okay, if the value of a is less than 1, that means the ROC includes the unit circle. Okay, the ROC includes the unit circle. Okay, so uh, ROC is outside a circle of radius. Now some other term is written, it can be correlated to DTFT that I am not explaining now. But some clue I have given here that it is actually integrable or Dirichlet condition satisfying. This function is integrable and it is a Dirichlet condition satisfying. So DTFT exists, that is written, but I am not explaining now because you will not understand here. So, and this you see that it is Z by Z minus A, Z by Z minus A. So that means it has one zero and one pole. Can you tell where the zero exists? The transfer function is Z by Z minus A. So any transfer function can be assumed as a ratio of a numerator and denominator. Okay. So in the numerator, for the values for which the functions become zeros. All zeros are what? For the values for which the function xz becomes 0 is called 0. That means magnitude becomes 0. Okay, so that's are called zeros. And poles are what? The values for which the functions become infinite. Okay, those are called poles. So at z is equal to 0, its function's magnitude becomes 0. At z is equal to a, function's magnitude becomes infinity. So 0 exists at z is equal to 0 and pole exists at z is equal to a. So these pole and 0 are plotted here. So you can see this circle, small circle at the origin represent the 0 for this transfer function, and this cross represents the pole that exists at z is equal to a. Okay, so both pole and 0 are plotted here. Now some property that if your xn signal xn is a to the power n un, okay, and a is greater than 1, say 1.1, so each time the signal is growing, okay, each time the signal is increasing as the time increases, since it is more than 1, it is increases. This is one case. Another case, so a is equal to 1, so it is simply a unit step. And another case, a is less than 1, so it is 0.9, so it is decreasing. So seeing this property of the signal, what should be the pole zero plot? Okay, pole zero plot for what should be the ROC? Okay, ROC, you see that it is outside the unit circle, outside the circle of radius. What for the first case? Can you tell what is the ROC of this case?
Sir,
First
greater
case?
than 1.
No. Anybody else? कोई और बताओ. अभिनव, शाश्वत, शाश्वत बताओ. कौन बताएगा? वॉलेंटियरली कौन बताएगा? स्पॉन्टेनियसली कौन बताएगा? Okay, that means you are not listening properly what I am telling. Okay. No, what is your name? Harshvardhan. Harshvardhan?
Yes, sir. 1.1,
Yes.
sir. Sorry.
Yes. 1.1. So it is, this is the 1.1 circle, radius circle. So ROC is outside this region
Excuse
is
me,
the,
sir. Your slide is
yes.
not visible.
Huh?
Slide is not visible now, sir.
Oh, oh. Okay. So this is the first case where ROC exists outside the circle of radius 1.1. The next case, ROC exists, and in this case you see the unit circle is not included in the ROC. Okay, since it is a pink color circle, it is outside the ROC, okay, not within the ROC. Inside the ROC, inside the, not outside, inside the, not means it does not include, the ROC does not include the unit circle, but it is inside. Okay? But in this case, ROC, in second case, ROC includes the unit circle. Okay? And in this case, where it is decaying signal, ROC exists outside the circle of radius 1. Okay, this is a blue region, and yeah, uh, here this includes the unit circle. Okay, so and also we have earlier studied, and this can be correlated with stability. How can it be correlated with stability? Can anybody give idea? Which one is stable system?
Sir,
Stable
the
signal.
middle one, sir.
Hmm?
And it's the middle one, sir.
Middle one. And what about the last one?
So the last one also. No, yes, sir. It is also stable, sir.
Yes, it is stable. So for stability, the what is the criteria? For stability, the criteria is be, first thing is that if ROC includes the unit circle, then it is stable. Okay, and also according to the Vibo stability, if you give bounded input, okay, the output should be bounded. So if this is your input signal, okay, where A is 0.9, so it is decreasing, so input is bounded. So for this case, output will also be bounded. Okay, that then it will be stable. So if it is input signal is growing, okay, so for it is increasing. So if for very high amount of time instance n, okay, it will be very high. So in that case, the system output will also be very high, so leading to instability. So this condition is related to stability. So you can directly tell from seeing the pole and zero plot, seeing the Z plane. This is what? This is Z plane. Okay. You can directly tell from the Z plane that which system is stable, which system is not stable. Okay, very important relation property that if the pole, okay, pole or the pole is there, from telling the pole you can see the magnitude of the pole is greater than 1, that means it is a unstable system. Okay, and ROC does not include the unit circle. ROC is outside the, if the ROC is outside the unit circle, ये ROC है इनपुट्स यूनिट सर्कल से बाहर है, तो वो अनस्टेबल सिस्टम हो जाएगा. यहाँ पे ROC जो है, के ROC जो है इसके अंदर यूनिट सर्कल है, ठीक है. सो that is the region, okay, the outside the circle of radius 0.9. Okay, the ROC is the outside the circle. This is the circle of radius 0.9. So is ROC is the outside of that circle, but it includes the unit circle of radius 1, pink one. So it is stable. And this is actually marginally stable. Second one, not fully stable, marginally stable. And this is totally not stable, this system. Okay? Because the ROC is outside the circle of radius 1.1, okay, and does not include the unit circle. Okay? So here now another case. You just go through this. If A is negative, okay, if A is negative, so in that case, this is alternating signal and increasing since it is 1.1. Okay, oscillating signal, but it is increasing. And here -1. So it is also oscillating, but not increasing, remaining constant, and it is decaying signal, but oscillating. Okay. And it is growing, and it is decreasing. So in these all these cases actually represents, first one is represents the unstable because the ROC is Here pole exists at minus 1.1, okay, and ROC exists this region greater than minus 1.1. So it does not include ROC. Okay, anyhow, you just go through it. The next, another case is, so we have discussed the signal a to the power n u n causal sequence. Now another sequence we take, that is anti-causal sequence, that is u minus n minus 1. Okay. Can anybody tell what does it mean, u minus n minus 1? What type of signal it is? U of minus n minus 1.
Sir, the
ये कैसे होता है देखने में?
sir, on the negative side, the signal will exist at amplitude minus at amplitude 1 for till minus 1. Afterwards, it will exist as 0.
Okay, that means from n is equal to minus 1 to n is equal to minus infinity, the signal value is 1, isn't it?
Yes, sir.
And from n is equal to 0 and more than that, it is 0. That is the left sided signal. So it is not 1 at n is equal to 0. Okay, it is 0 at n is equal to 0. Okay. And after that, it becomes minus 1.
Sir,
So if,
excuse me, sir.
yes,
Sir, actually, one of the student is not added, sir, in the teams. Can you add him, sir, please?
who has not, he has not, okay, now is it visible?
Yes, sir.
Okay. So another case is, that is anti-causal sequence. For anti-causal sequence, what should be the Z transform? So you see that xz is what? Summation of this n is equal to minus infinity to infinity x of n z to the power minus n. Now in that case, the function exists, since the function exists from n is equal to minus 1 to minus infinity. Okay, so or minus n is equal to minus 1 to minus infinity. So we take only that limit. Okay, and for other values of n, this is 0. So we take only this one. So it is a to the so minus is taken outside. Okay, and then it is a inverse. Okay, because z inverse term is there. Z inverse term is there. So we take here uh, since it is minus a to the power n z to the power minus n. Okay, minus a to the power n z to the power minus n. But since n is negative totally, so we just take the limits of n is equal to minus infinity to infinity and keeping a inverse z. So for n negative, this exists, and what should be the value? What should be the value of it? You see, if you just hear some calculation they have made, that this is valid, the xz will exist if a inverse z is less than 1. Okay? A in last this expression, you see that you can calculate it other way. Okay, you can calculate it other way to find the series. Finally, we will see that this will be finite, xz will be finite, or it will converge if A inverse Z is less than 1. Okay. Like other case, in the case of causal signal, what we have seen that AZ inverse is less than 1 or mod Z greater than 1. But in this case, A inverse Z is less than less than 1. Okay. And here A inverse Z, that one was AZ inverse. Now here it is A inverse Z. Okay. Mod Z less than mod A. So that means it is less than some value. Within some, if that A is what is a, it is that thing, Z is what, it is a complex number, R into e to the power j omega. So R is the radius of that circle formed by the phasor. Okay. So that radius is less than A. So it represents the area inside a circle. So anti-causal sequence represents in Z domain, its ROC is a inside of a circle, and in causal sequence ROC represents outside the circle of a circle. Anti-causal inside of a circle of some radius A, and causal sequence ROC outside of a circle of radius A. So this way uh, it is different. Okay, anti-causal sequence. Now you can go through this, that what should be the different pole zero plot. Okay, pole zero plot for this kind of signal. Okay, that is anti-causal signal minus a to the power n u minus n minus 1. Okay, whose here you see that actually uh, uh, let me do one thing. Yes, it is one. Okay. So it is 1 by 1 minus AZ inverse. For both the case, the Z transform is same for causal and anti-causal. For causal, it is 1 by 1 minus AZ inverse. And anti-causal, also it is 1 by 1 minus AZ inverse. But there are differences in the ROC. For causal sequence, ROC is mod Z greater than A. And for anti-causal sequence, ROC is mod Z less than A. Inside circle, and that one is outside circle. Now in this case, if you plot A is equal to 1.1, okay, 1.1. So very carefully you see that this is the blue circle is the circle of radius 1.1. Okay, 1.1. Now the ROC exists within this region. This is also shaded some gray or light, very light blue color. Okay, this one, this is also ROC. Now here unit circle is within the ROC. Unit circle is within the ROC of this anti-causal sequence. So this kind, so now coming to the equation, the signal plot. Signal plot is minus a to the power n u minus n minus 1. Okay. So as the n increases, in negative direction. Okay, that is -1, -2, -3. So power of A, okay, that is A is what? 1.1. So 1.1, it is power of n decreases. So it is 1 by 1.1, then 1 by 1 to the power 1 by 1.1 to the power 2. So in the denominator the value is increasing. So overall the value is decreasing. Okay, as n increases in negative side, the signal is decaying. Okay, this is a causal sequence, and if the impulse response of this kind of if the impulse response has this kind of function, that is, let us say in place of xn it is hn. Okay, in place of xn it is hn, impulse response, and the impulse response is decaying and it is summable. Okay, it is summable. So it is Bibo stability, that bounded input, it is bounded input, and the Bibo stability tells that impulse response is summable. So if you add all these values, since it is decreasing, the output, the summation of h of n will be finite. So that's why this is stable system. This one. So for causal sequence, don't see the difference. For causal sequence, the if the value of A is more than 1, then it becomes unstable. But for anti-causal sequence, if the value of A is 1.1 or more than 1, then it is stable system. Okay. Similarly, opposite is true for anti-causal case, where if its value is less than 0.9, so signal exists in negative side and it is increasing. So by its summation is, if it is a h of n, okay, it is, you cannot define. So summation h of n, that is the conditions for stability, is that impulse response is absolutely summable. So if you take sum of all these magnitudes, all these values, then it will become infinity. So that time these signals will become unstable. Whereas in this case, a 1.1, it is decreasing, so it is summable, so it is stable. Okay. So I hope it is clear, isn't it? Have you understood this? Harshvardhan?
Yes, sir. Yes, sir.
Okay. So one more property I am showing you, that if the signal is both sided, okay, so that is xn is equal to b to the power mod n, b to the power mod of n, okay, both sided signal. So it is a non-causal sequence. Okay, both causal and anti-causal. Causal part is un and anti-causal part is u of minus n. So for causal sequence, causal part, the ROC is mod z greater than b, okay, outside a circle of radius b, that is this region, this region. Now for the anti-causal case, mod z is less than, mod z is inside of a circle, mod z is less than b. So so this radius is, here actually you see that its ROC is mod z less than 1 by b. Okay, if you calculate it, you will get it. Mod z is less than 1 by b. So radius, a circle of radius 1 by b. Okay. So the ROC exists within two circles of radius b and radius 1 by b. Okay. So that is the concept. Okay. Here some problem, I hope it is there, because b and 1 by b, this one is 1 by b, is this should be 1 by b, some fault is there, and this is b. Okay, so it is outside the radius of circle 1 by b. Okay, I will check it. I will make it corrected. Okay. So we just go through these properties, okay, of Z transform, and also prepare for the inverse Z transform. So one thing is that I have to take some extra class. This Wednesday I will not be available. So I will inform you when I will get time. I may take the class, but this Wednesday is not possible. Okay, so I have to arrange class for this Wednesday and maybe Thursday also. Okay.